Okay, so tomorrow you have part 2 of an exam over organic compounds. So if we were to go all the way back to the beginning of organic compounds, we would start with knowing the numbers of parent chains from 1 to 10. So what are they from 1 to 10? Those are derivatives. Okay, so we're doing this correctly so far. Okay, so that was one of the first things that we had learned. Then we had learned derivatives, which only goes down this far. Then in general chemistry, you would go this far. And then in the organic chemistry class, you would go that far. Because what we see here, there is 2. This one is 2 more, which then gives you a total of 4. And then in here, there is 4. So then we add that to what we have together. So at the senior level, you would have 8 total derivatives to know. That's why we take this in a progressive manner. You learned the first 2, then in general chemistry, you add 2 more. Then with the senior level organic chemistry, you add 4 more to that total. You just have to know what they're called. Okay? So our first 2 derivatives then were called what? Okay? So a methyl group has this formula. Okay? What does an ethyl group have? Okay, so then after that, I would be led to believe that ring structures came after learning these. So what is a ring structure?
It's a shape that
Where does the first ring structure start?
Can methane and ethane be a cycle?
No. So that answers that question. Because you have to have a geometrical shape, because ethane is just a line segment, and then I suppose you could say methane would just be a dot. Okay, so that means I should use a darker color than that. Providing we think we can see that, this ring structure is called what? So I'll even put that on tape. That's the success of our track team. They run like they're late for science. Okay. Then what is this ring structure?
That would be cyclobutane.
Okay. Then
That would be cyclopentane.
that's not a very good pentagon, so we'll try that again. Okay. Then I think I'll move over to this side.
That'd be, I think, cyclohexane. I said it first. You think so now? No.
Okay.
I'm not sure yet. Oh, yeah. You're right. Oh, that's cyclohexane, maybe?
Okay. And then, okay, so I'm just going to do this so we don't get them confused. Then this one's a little more difficult to do.
Like an octagon?
Well, that's not what I wanted to do. That doesn't look very good. Sometimes maybe it's just better to, and I know that's a little light, but you can kind of make out the shapes of it. Sometimes maybe it's better to do this.
That's a good one. That's a good one.
Okay? So I'm not even going to try to do cyclononane. And then, of course, you'll never have to do cyclodecane. I mean, there's just no way we want you to waste time on doing that.
Like a test, would it have to be like in that shape, or if like I make it look stupid, would that matter? Just don't make it look stupid.
Well, we don't want you to do like with a heptagon. We don't want to see something like that. We don't want you to draw a Pac-Man. Okay? So we might think that 1, 2, 3, 4, 5, 6, 7, that is a heptagon. That is not correct. Okay? If we wanted you to draw a Pac-Man or a Miss Pac-Man, just put a bow on it, then we would ask you to do that. But we're not drawing Pac-Man. Okay. So then we learned other derivatives besides these two. That's one. Chloro's a derivative. What else? Bromo, iodo, and what? What do you, okay, so you started with chloro, then we said bromo, then iodo, and what do those three have in common? They're in column 7. Those are halogens. So the only remaining halogen is which one? Fluoro, with fluorine or fluoro. That's right. So then here is your halogen derivatives in order. Okay, so fluoro, chloro, bromo, and iodo. Okay, then what is a special ring structure?
It's a B.
It does start with a B.
Oh yeah, and it has a circle in the middle.
Okay, and what is the significance about this other than it's got double bonds in it? And the difference between that and cyclohexane then, which one of those is unstable? Okay, so we're pointing, so we're going to call this letter A, this is letter B. Okay, so which selection or letter is highly unstable? I hear A and I hear B. Why would we pick A? Because it's what? Well, in a matter of sense or speaking, yes. But why would we pick letter B then?
I've already got breast cancer.
Well, that doesn't mean anything.
Oh, because isn't it
Okay, what this means is typically we associate having these double bonds in here as being highly unstable, but that can't be any further from the truth. This is a very highly stable compound, benzene. Yes, it is illegal because it was used as a cleaning solvent. That is true. But this, however, is highly unstable. It's much easier to react with cyclohexane than it is benzene. Okay? So, for instance, if we put a couple different derivatives on there for letter B or cyclohexane, how do we start that?
1 fluoro, 4 methyl.
Okay, everything you're saying is right, but how did you know where to start?
Because fluoro comes before methyl.
Okay.
Methyl, and it doesn't really matter what we
So
use.
1 dash what?
Fluoro. Do you have to put that word?
Okay.
4-methyl.
Yes, you have to put the
Heptane. Cycloheptane. Hexane.
Okay. How would that be different for this then?
It would be 1-fluoro, 4-methyl benzene.
1 fluoro dash 4 dash methyl benzene. Seems complicated, don't it? It isn't? Okay, good, good, good.
If you didn't understand it, then it'd be confusing.
Yeah, if you came in and you didn't know a single thing about this,
It would.
and you
And but also keep in mind when I'm glad you said that this doesn't seem difficult. There is simpler ways of naming that, a lot simpler,
Like what?
but because that does have a common name. Well, we wrote that. It also is known as toluene, okay? But we're not going to go into that because that you just have not learned that yet. Because the International Applied Unit of well, that doesn't sound right. It's called IUPAC. It's the International Union of Applied Chemists. There we go. Had already established a lot of these naming concepts that, okay, it just makes that a lot easier. But we're not going to go into anything like that. Okay, that's more so of a senior level application. Okay, so that is the order that we learned these, but it might not be the complexity that we have learned. Okay. Okay. So. Okay. How would we start that?
It would just be hexane because the parent chain is 8 and there's no third.
it's octane.
Octane, you're right.
Okay. I think 2, 4, 6. Yep, there's 8 there. All right. So then I want to do this in a specific manner. Okay. All right. So we had already established the
3,3.
the parent chain is what? We've established that. Okay? So we know that that is octane. Okay? So is there anything branching off of that octane? Yes, there is.
Wait, can a bromo or a BR branch off of another? Can I be a bromine that branch off of another bromine?
No.
Can it
Well,
branch off of
I'm
chlorine?
for an inorganic compound, I believe it can, but not for, yes, but not for an organic compound, at least not for our practical purposes. So, what is branching off of that octane?
Bromine and an ethyl group.
Okay, so now, when you have two of the same derivatives, how do you account for that?
Put 3,
Or 3,3.
Okay, So are we going left to right or right to left? Okay. So then you had said on our third carbon and our fifth. Okay. So,
3,3
Dibromo.
okay. So you do have to count for both of them. 3, comma 3. Okay. Then dibromo dash
5-ethyl.
but that would be correct. Okay. Usually it's when we are in general chemistry, we possibly run into we disregard these prefixes. So what would happen if those were, what about if we had done this, a chlorine derivative? Would we have to change the order?
Yes. It'd be 5-chloral.
No, because bromine would go
Alphabetical.
Yeah.
Okay?
Oh my.
You would think so, but what do we do with prefixes? You disregard these prefixes. Okay?
Just the first 3 letters.
So even though the C comes before D, we understand that, but you disregard the prefix, go by the letter B. Okay? Now, that gets to be a little more tricky when you use isopropyl or isobutyl groups. There, you use the prefix. Again, the International Association of Applied Chemists, when you're naming these, they applied the rules and said years ago that you disregard prefixes except for something like that. This is a prefix. That you use the letter I, not the letter P. Here, you disregard the letter D and you go by the letter B. Okay? But you don't have to worry about that. I'm sorry, what's your question?
What would ISO be like? What number is
ISO. 3, probably.
That is an isopropyl group.
Pass that in.
Because, and again, it's a derivative because what compound is that? Propane. So just like a methyl group is a derivative of methane, an isopropyl or a propyl group is a derivative of propane. Just one of them things to where you will learn that eventually, just not this year. Okay. Then what organic family is this? It's a saturated what? Okay? Inside the box, we've established, okay, ANE means that it is an alkane. How could you change an organic family?
Take one of the carbons.
You put a double bond or
Okay?
without making an acid.
Okay. First of all, what is the organic family that we have?
Butane. Nope. Would it be butane? But you just have to pick one.
Okay. I don't believe I've heard the correct answer yet. Okay, that's the organic family, so how's that going to change from an alkane? Okay? And once we've changed that organic family, this has to be tied with numbers. That does not, because alkanes are saturated. Alkenes are unsaturated. So what that means then is we've established that this is butene, but what is it? Can we leave it as butene?
I think so because it's on the first carbon.
No, it's not.
If you go right to left, it would be on the first carbon. We ain't geeking.
Gotta count from the longest.
Okay, so is 3 our longest chain?
No, you're right. No.
1, 2, 3, 4, or 1, 2, 3, 4. So that being said, okay, where is our double bond located? After which carbon? Okay, so then is there anything branching off of that butene? Okay, and on which carbon? Well, here, the first or the second?
Second. It's on the second.
Okay, so it's on the second. So we've got 2 dash what? 2 dash what? 2 dash methyl. Anything else? Okay, so what is the significance of that 2?
It tells you where that double bond.
Since it's an alkene, this 2 is making reference to the alkene. Just like we said, an adverb will express or modify what a verb is. So we are quickly going through these compounds or quickly discussing the compounds, okay? So obviously discussing is the verb. We're quickly doing that. The adverb tells you how you're doing the verb, which is discussing, and it's going fast because it's quickly. Okay? What is a different organic family we have discussed? We've done alkynes. We really don't spend a whole lot of time on that, so I don't believe there's going to be any alkynes on your paper tomorrow. There's alcohols and there are acids. That's correct. So how is it that we know we're looking at either one of those?
Alcohols have OH.
Okay? So go ahead and just name an acid. Okay? So if you didn't hear anything past that, what can we presume about pentanoic acid?
There's 5 carbons.
Okay?
Can you do cyclopentanoic acid?
You can, but not for what you're thinking, though. Okay? So in this case, you correctly said it's COOH. So typically, can you put it on this carbon or this one? It doesn't matter. So which one would you like it on?
Right.
Okay? So what is it that we have to put on there?
A double bond to an oxygen. And on top.
I was turning off my ringer.
Okay?
And then
You had asked a question. Do you really want to know the answer?
no.
What was my question?
Can you have cyclopentanoic acid? Not for the reason you can come up with something similar to that, but it can't be pentanoic acid, cyclopentanoic acid.
No.
Okay.
Will we get to learn it though in high school or?
Mm-hmm.
Tom, you're in high school, buddy. So got 3 more years down.
He means later on
Later on.
in high school. Okay. So then, what happens if, can you put an ethyl group on here? Okay. Now, there's got to be a reason that we would say that. Okay? Because every time you name these compounds, the very first thing you need to do is find what? The longest continuous chain. And we've established that this would be 5, correct? So pentanoic acid. Now, is there anything branching off of this pentanoic acid?
Well, yeah.
Do we need to change anything with it?
It would be
What is your longest continuous chain?
6.
1, 2, 3, 4, 5, 6. Okay? So if we do that,
that's the exception though, isn't it? Where you don't have to do that.
if we make this our longest continuous chain, what do we call that?
I don't know. It's nothing. So don't you make an exception? You have to do 2 ethyl, don't you? Yes, but
You need to say that again, but make sure everyone's listening to you.
that's the exception.
This is an exception to that, because this has to be part of your parent chain, because this is your organic family. That has been established because of that. Okay?
You know, when we asked if we had to do anything, I was the only one who said no.
Okay, we're not that far.
Would it be 2 ethyl pentanoic acid or?
Now, what if the carbon?
So this has to be number 1. This one's number 2. And then, of course, moving so on and so forth. So on our second carbon, what do we have? Okay?
What if the ethyl group was on the first carbon?
Can't.
Can't. Okay.
Okay? And this is why.
Impulsible.
Because that oxygen is taking it.
Because if you did that,
That carbon has 2 electrons.
it's got 5 bonds. And then, well, what about if we did this? Okay? That actually is possible. But that's a ketone now. That's a different organic family. We don't want to discuss ketones. We can, but
We're okay.
I think you're probably better off not knowing what ketones are until later on. Okay? Or you could even chop 2 of them off. Now you have an aldehyde. So again, none of that means anything to you, and nor should it.
Wait, I have a question.
Yes.
Since there's an oxygen right there, well, wait, would it still be the aldehyde if it didn't have an alcohol?
If we took this off,
Yeah.
that is an aldehyde now.
Okay, so would you still do the same thing with an alcohol? Like your parent chain wouldn't have the ethyl in it?
Okay, so if I'm interpreting your question correct, is this what you're asking?
No, like if there wasn't an alcohol on it. And it
Okay,
was-
so there's no alcohol, no OH group on there.
Yeah. it
Then
was
what?
The double bond to the oxygen.
Okay, up here?
Yeah.
Okay, double bonded oxygen.
Yeah, and you know how there's an exception for the acid.
Okay.
Would it be
Same
an
thing
exception
that.
for the alcohol or whatever that is?
Well, we know we don't have an alcohol because there's no OH group on here.
Yeah.
But
like, do you
whatever
still
that's
have to
called, what did you say
that
that's?
part? Like, would your
What
parent
did you say
chain
that
be?
group is called?
What, aldehyde?
Yeah. Would you make an exception for that aldehyde to still be?
Yep, this would still be your first carbon. Okay, so then if that was on there, then your organic family is now an alcohol, which that doesn't necessarily have to be your first carbon, but we won't do that at this level. Okay?
So if it's an alcohol, that'd still be our first carbon.
That's why we're saying we wouldn't do that at this level. All right. So then, when it comes to that of alcohols, somewhere on Okay. You can establish what is your organic family. Okay, so it's an alcohol that has a 7 carbon chain to it. Okay, so when we put this in a box, why is that important? Because that is telling you that you have a hydroxy group or an OH compound somewhere on there. So, if that is the case, where are you starting on here to name this compound? You have to start here because this is your organic family. Then, what would you do after that?
Is that H3C basically the same thing as CH3?
Yes, because you can't write it like this. Well, you can, but what type of bond is this to this? It's a carbon-to-carbon bond, right? What are you illustrating here? Carbon to hydrogen. It doesn't do that. And I know it looks silly, and we wouldn't count off for that, but this is more accurate because it should be a carbon-to-carbon bond. Okay. So, are we going clockwise or counterclockwise? It does not matter. Okay? So, typically, I think going clockwise makes the most sense, is the easiest. So, what carbon number is this? What carbon number is this? What carbon number is this?
5.
Okay? So 1, 2, 3, 4, 5, 6. Okay? 7. Okay. So then, what we have in the circles here, how do we account for that?
It would be 3, 6 dimethyl Holy, she wants a bogey.
Okay. Don't forget the cyclo, because it's a ring structure.
You don't have to add anything for the alcohol and the
Oh, yes, you do, because we probably should, even though it's probably just understood that it's on the first one. So that's what we do at the senior level, but maybe 3, 6 dash dimethyl dash 1 dash cyclohexanol.
Do you have to do that?
Yes. We're going to do it at this level because we want you to know why it is that you're doing that. Because once you establish this as being number 1, you're saying that that is your organic family, and that would be correct. All right. That is pretty much everything that we've done. Okay, we went through your 10 I suppose you could say alkyl families, methane down to decane. We discussed your derivatives, whether they're alkyl derivatives like CH3, C2H5, or halogen derivatives like fluorine, chlorine, bromine, and iodine. Okay, we talked about alkenes. We talked about alcohols. We talked about acids. There's perhaps one thing left that isomers that we possibly struggle with. You will not be drawing any amino acids or monosaccharides like glucose or anything like that tomorrow. You will not be naming them either. We've evaluated you on that yesterday. Okay.
Praise the Lord.
So we can do this really, we'll work on it together because this is what the juniors had done. Okay? And they were responsible. We asking Google or what? I just heard I know what it sounds like when we set a phone down. You're just done?
No, I just set my phone down.
Well, what was it picked up for in the first place?
I don't know.
this was a little twist that we threw at the juniors, and some of them are seniors. Okay, there are a few derivatives that you could do, but I said you need to give the only two existing isomers that are butane based. Okay?
So your longest parent chain is butane.
That is correct. No, I'm sorry, pentane. They would have to be pentane. How did I ask that? Hold that thought. Yes, the only two isomers that would exist as butane molecules. So, we'll point you in the right direction. Okay? I think you can come up with one of them, so they got to be methyl groups. Where? We okay? All right. Just tell me.
Could you put it on the second carbon?
Okay, so we can put a methyl group here.
And then could you put it on the third carbon at the bottom?
See, that's the more difficult one that I didn't think anyone would come up with. That is one. That's 2,3 dimethyl butane.
And then could you
It's really close to this one.
do you flip it?
Nope.
Yeah, just put the one on the bottom on the top. Two on top.
Like this.
No. Put
Nope.
Put the one on the you take one and you put it beside it on the third carbon.
Over here.
Yeah, right there.
That's the same compound. Because this is 2,3 dimethylbutane. This is 2,3 dimethylbutane. Say that again. I thought you said what it was we wanted to do.
One below and then one.
On the same carbon? Mean like this? Those are the only two isomers that would exist as butane molecules. That's correct. So, yes, I was surprised. To me, you got the harder one done first. I thought this one would be a little more obvious. But
Do you think most of them got it?
I'm going to go with no. That's why I said we'd do this together. Okay. Anything else?
I don't think so, since we're not doing the hard stuff on the exam. I think we're chilling.
So, nothing else.
I think that I'm just gonna struggle with the stuff from last week. I think I'm still gonna
Oh, how soon we forget. Going once.
Extra credit.
Going.
extra credit.
Is it too late?
No.
No, you said going twice, not.
All right, hold that thought. Okay, after some students giving some answers away. Bonus one, what was the nickname of Laura Ingalls given to her by Pa Ingalls in the show Little House on the Prairie? It was blank. And then bonus two, the show Tool Time takes place in what U.S. city? It is the show that we watch from time to time. Okay, so X marks the spot. If you want more points, free points, has to be turned in tomorrow and has to be written out. You just can't write the answers. Okay, exam tomorrow.